Welcome to this video. So in this lesson, we are going to go over some continuous random variables. Okay, so we know that a continuous random variable is just simply a variable that is defined over some certain interval. Okay, so let's say x is a member of some certain interval. We say a to b. Okay, so this x here will be considered as a continuous random variable if it's defined over an interval or intervals. Okay, so that's what we are going to be doing here. So the basic thing that you have to know here is you have to know how to integrate, first of all. Okay, so from your first semester, I'm sure you did a little bit of integration. Okay, so you have to know how to integrate. And then you also have to know the basic rules, okay, that we go over when we are doing our continuous random variables. Okay, so this still applies when we are talking about discrete random variables. So the first one is that the probability, okay, should be between 1 and 0 for all the x in a certain interval, let's say a comma b. Okay, and then the second one is that the integral, okay, from the lowest limit that you have in your interval, let's say the lowest limit there is a, and then all the way up to b, okay? This integral here should give you 1. Okay, so the integral over the whole interval that you've been given there should be giving you 1. So this is one of the rules that we are going to be using. And then another important thing is the formula for finding the mean, okay, or the expected value. Some people, they say the average. So we're going to say the expected value, you indicate it by e of x in the bracket. It's going to be equals to the integral from the lowest to the highest, okay, of x multiplied by the PDF, which is f of x. So this one here, we're going to be using it to find the expected value of x. Then we also have to know the formula for variance. So variance of x is equals to the expected value of x squared minus the expected value of x, okay, the expected value of x, and then we square it. So this means that we need to find the expected value of x squared when we are finding the variance. So we're going to be finding the expected value of x squared, okay, which is just the same thing that we are seeing here. But this one here, where there's x, okay, we will be putting what? X squared. And then we say our function f of x and then dx. Okay, and then we know that the standard deviation is always the square root of this same variance here. So these are the formulas that we are going to be using as we'll be tackling these questions on what? Continuous random variables. Okay, so if you missed the class for the discrete random variables, you can just search for it on my YouTube channel. You're going to find some videos there. Okay, but if you want the full videos, you find them on our website. Okay, you can check it in the link of this video. Right, so let's look at this question here. So they're saying a hospital monitors the time in hours it takes for a patient to recover from a specific treatment. The recovery time follows a continuous probability distribution with the following PDF. Okay, so this is the PDF that they have given us, and they have given us this PDF um, in terms of an interval. Okay, they have given us this PDF in terms of an interval. All right, so the first question here, they're saying verify that the given function is a valid probability density function. So how do you do that? Okay, so you just have to check that the integral over the interval that you've been given, which is 0 to 3 of f of x, is equals to 1. So if this integral here is equals to 1, then we're going to confirm that this PDF here, okay, is indeed a valid PDF. So let's look at A. So we're going to say, okay, the integral of 0 to 3, and then our f of x is just 2x over 9. And then we're saying dx. So we are integrating this guy here. Okay, so how do we integrate such um, functions? Okay, so when we're integrating here, we just use the power rule. So we add a 1 to this power of x, okay, and then we divide by that power. So what we're going to get here will just be, okay, if we integrate this, it will be 2x squared, okay, divided by, there's a 9 here, I'll put it there, and then I'm going to say multiplied by the new power here, which is 2. So I'll put 2 here, okay, and then we have the limits, which is 3 and 0. So this gives us what? We see that these 2 and these 2 will cancel. So what we are remaining with is x squared divided by 9, okay? Then we have 3, 0. So now we just have to replace the limits there. Okay, we just have to replace the limits. So the first one will be 3 squared divided by 9. Okay, where there's x, I've put this 3. Then I'm going to say minus. Where there's x, I'm now putting 0. So this is 0 squared divided by 9. So this one here gives me 9 over 9 minus 0 over 9, which will just be 1 minus 0, which will just be 1. So we see that the integral over the whole limit there, okay, is just what? 1. So this confirms that the f of x here is indeed a what? A PDF, because we've shown that the integral, okay, over this whole interval here is actually equals to what? To 1. So that's how you show that something is a valid PDF. Okay, so now let's look at B, where we're finding the mean. Okay, so they're saying find the mean recovery time for the patient. So the mean is the same as the expected value or the average. Okay, so we said the expected value of x, which is the same as the mean, is just going to be equals to the integral, okay, over the interval that you've been given, which is 0 to 3 of x, and then you multiply by the function. So the function is 2x over 9. So it means here I have the integral of 0 to 3 of 2x squared divided by what? 9. Okay, so by, okay, you're supposed to put dx, and then even there you're supposed to put dx. Okay, so let's put dx here. So by the rules of integrals, okay, we're allowed to get this 2 over 9 and take it in front of the integral. So what I'm going to have is 2 over 9, and then the integral of 0 to 3 of x squared dx. Okay, so this gives me 2 over 9, and then now I can integrate x squared. So it will be x to the power 3 divided by 3, and then I still have the 3 to 0 as their limits there. So I'm going to have 2 over 9. And then here it will be, I replace this x with 3. So it will be 3 to the power 3 over 3 minus 0 to the power 3 over what? 3. So this is what I have. And then this is going to give me 2 over 9. Okay. So 2 over 9. And then in the brackets there, what am I going to have? So I have 3 to the power 3 divided by 3. So we can cancel 1, 3 with 1, 3 there. So we're going to remain with it. 3 to the power 2. Okay, and then this is 0. So it means inside there, I'll just have what? 9, like this. Okay, inside there, I'm just going to have 9. So that one, it means our expected value will just be 2. Because this 9 and this 9 will cancel. Remember, this 9 is over 1. So this one will cancel with this one. If you don't want, you can say 2 multiplied by 9 to be 18 divided by 9, which will just be what? 2. So the mean recovery time will just be the 2 hours. Okay, and then C, calculate the variance of the recovery time. So how do you calculate the variance? Okay, we need to find our expected value of x squared. So let's find the expected value of x squared. Okay, because we'll need it in the formula for the variance. Remember, the variance of x is given by the expected value of x squared minus the expected value of x, and then squared outside. Okay, so notice that here the squared is on the x, here the squared is on everything. So we've just found the expected value of x. We said it was 2 hours. Okay, so now for us to find the variance, we need to find the expected value of x squared. So expected value of x squared will just be equals to the integral from 0 to 3 of x squared multiplied by 2x over 9 and then dx. So this will give us the integral from 0 to 3. Okay, so x squared multiplied by 2x, it will be 2x to the power 3 divided by 9 dx. So by the laws of integrals, we can take this 2 over 9 in front. So what we have is 2 over 9, then the integral of from 0 to 3 of x to the power 3 dx. So this one is going to give me 2 over 9, and then now I can integrate this part. Okay, so integrating x to the power 3 just give me x to the power 4 divided by 4. So it's what I'm going to write here. And then I still have the limits 3 and 0. So this is going to be equals to 2 over 9. Okay, and then here now you can substitute your 3. So it will be 3 to the power 4 divided by 4 minus 0 to the power 4 divided by 4. So what does this give us? To be 2 over 9. Okay, 3 to the power 4 is going to give me 81 divided by the 4. Then this one becomes 0. So we can leave it out. Okay, so here it means that our expected value of x squared will just be equals to, okay, expected value of x squared just be equals to. So here we can do some cancellation. So we can say 9 into 9, 1, 9 into 81, it's there 9 times. And then 2 into 2 is 1, 2 into 4 is 2. So we've just remained with 9 over 2 here. Okay, but if you want, you can just say 2 multiplied by 81, and then you divide by 9 multiplied by 4. It still gives you the same answer. So this would be just be 9 over 2, which will be 4.5 hours. Okay, so this is our expected value of x squared, but our focus, okay, or our goal is to find the variance. So variance is equals to expected value of x squared, which is 4.5, minus the expected value of x, but we square it. So the expected value of x was 2, and then we square it. So we're going to have 4.5 minus 4. So this will just be 0.5. Okay, so it means our variance there is just 0.5. Okay, and then we can go to the next one, which is saying determine the standard deviation. Okay, so how do you determine your standard deviation? Okay, so as long as you found the variance, then the standard deviation is not hard, because the standard deviation is always the square root of this variance. So the square root of the variance of x, which will just be the square root of 0.5. So what is the square root of 0.5? You just punch it on your calculator. Okay, so you should get approximately 0.707. So this here will be our SD, or our standard deviation. So we are done with question A, B, C, and D here. Okay, let's look at question E. Okay, it's still the same function, this one here, but now we have more questions here to solve. Okay, so question E, the same, find the mode of the recovery time distribution. Okay, so our PDF is this one. 2x over 9 for 0 all the way up to 3, and then it is 0 elsewhere. So meaning that whenever you pick a value of x that is not in this interval here, okay, then the probability there will just be 0. Will just be 0. That's what this means. So we want to find the mode. Okay, so what is the mode? So from your statistics, we say the mode is the entry that has the highest frequency, right? Okay, So now when it comes to the continuous random variables, the mode is the value of x that gives us the highest probability. Okay, the value of x that gives us the highest probability. So in this interval here, if I get 0 here, I'm going to get my lowest probability here. If I say f of 0, that will just be 0. So this 0 is my lowest probability. Okay, so my highest probability will be when I replace what? When I replace 3 into this thing. So f of 3 to be 2 multiplied by 3 and then 9. So this will be 6 over 9. So 6 over 9 here is my highest probability. So what value of x gives us the highest probability? That will be our mode. So our mode here, we're just going to say is x is equals to what? 3. Because from this interval here, the x is equals to 3 will be the one that gives us the highest. Okay, the highest probability, which is 6 over what? 9. Okay, and then we can look at F. So F, they're saying determine the median recovery time. So for us to find the median recovery time, okay, and I can also see that on G here we have the Q1, Q3. So for us to find those ones, we need to find the CDF. Okay, so how do you find the CDF? You integrate the PDF. So here we've been given this PDF here. Okay, it's a piecewise PDF. So there's this part and this part. So when you integrate 0, you're just going to get 0. Okay, so in this case, we're just going to ignore it because it's 0. But if you had another function here and then you're finding the CDF, you need also to integrate this part. Okay, but since it's 0, we'll just integrate this part here. So we're going to say our CDF, which is indicated by capital letter F. Okay, so we can say our CDF, we can say capital F of M because we're finding the median at first here is going to be equals to the integral, okay, from the lowest value in the interval that you've been given. Okay, so the interval that I've been given is 0 to what? To 3. So what is the lowest value in this interval? Okay, I'm just going to write 0. It's the lowest one. And then I'm going to a limit here, which is not given a number. So I'll just say 0 to m because I want to find m, which is my what? My median. Okay, so you don't put 3 there. When you're finding the CDF, you put a variable there, like m, t, whatever variable that you can put there. And then now I'm going to get my f of x, which is 2x over 9. Then I said dx. Okay, so my m here is to find this m. So we know that the median here is the value, okay, that uh, divides the data into 2 equal parts, right? So if I'm finding my median here, it means that my CDF should be equaling 0.5. Okay, so that's how we're going to find this m here. Okay, so now let's integrate this part and then equate it to 0.5 and then try to find the value of m. So when we integrate this, okay, from our previous question, we got x squared over 2. Okay, and then you have m, 0. This should be equals to 0.5. So we're putting 0.5 here because we're finding the median. Okay, so the median is like the middle number, so 0.5. Okay, and then from here, these two and these two will cancel. I'm going to remain with x squared over 9. Okay, or maybe we substitute first. Okay, so let's substitute first. So we can say we have 2 over 9. And then inside here, we're going to have m. Where there's x here, we put m. So it will be m squared divided by 2 minus. Where there's x, we put 0. We're just going to get 0. Okay, so this should be equals to 0.5. Okay, and then let's try to solve for m now. So when we try to solve for m, what are we going to get? 2 over 9. And then I have m squared over 2. Okay, this is equals to 0.5. So this is the same as 2 cancel. I have m squared over 9 is equals to 0.5. Okay, so cross multiply, what do we get? We get m squared is equals to this 0.5, we multiply it by 9. I'm going to get 4.5. Okay, so remember our aim is to find this. Our aim is to find this m. Okay, so let's square root both sides. So if I square root this side and also square root this side, okay, I'm going to get that our m is just going to be equals to the square root of 4.5. So we just get this the positive square root. Okay, so the square root of 4.5 is approximately 2.12. Okay, so it means our median recovery time is about 2.12 hours. So this is our median. Okay, and then to find the Q1 and the Q3, we're just going to be equating this CDF to different numbers here. So the median is also known as Q2. Okay, and then we have Q1, and then we have Q3. So when you're finding Q2, we said you equate the CDF to 0.5. Okay, and then when you're finding for Q1, you have to equate this, you have to equate the CDF to 1 over 4. Okay, so in decimal, the 1 over 4 is the same as 0.25 when you're finding Q1. Remember, our Q1 is just the middle value of the lower half of the data set. Okay, and then Q3 is the middle value of the what? The upper data set. So if you are finding Q3, it means you equate your CDF to 0.75. Okay, or you can say 3 over 4. Okay, so in other words, if you will find it hard to remember this, let me write them in a simple way. So if you are finding Q1, okay, you equate it to 1 over 4. Q2, you equate to 2 over 4. Q3, you equate to 3 over 4. So when you find this as a fraction, as a decimal, it will be 0.25. This one, it will be 0.5. This one here will be 0.75. So that's where these are coming from. Okay, these are just quartiles. So let's find the Q1 and the Q3. Okay, so I'll just get the CDF. So the CDF, okay, we can say of M, we found it was M squared divided by what? 9. This is what we found. Okay, found it was M squared divided by 9. So now we want to find Q1. Okay, so we can say CDF of Q1. If we integrate it and we do whatever we did, we're still going to get Q1 squared over what? 9. So since it's Q1, we're going to equate this part to 0.25. So it will be Q1 squared over 9 is equals to 0.25. So Q1 squared is equals to 9 multiplied by 0.25. Okay, so we do that on the calculator. 9 multiplied by 0.25 is giving me 2.25. Okay, and then from there we square root. So Q1 will be the square root of 2.25. Okay, so the square root of 2.25 is what? Okay, so it's about 1.1. Yeah, okay, so the square root of 2.25 is just 1.1. So it means our Q1 is just 1.5. Okay, so we can write it here. Q1, we found it was 1.5. The median, which is the same as Q2, we had found that it was about 2 point something, right? It was 2.12. So now let's find the Q3. So Q3, we're just equating the CDF to 0.75. Okay, so I'll just write q3 squared divided by 9. Okay, so some people may be asking, where is this coming from? This one here, we said it was the CDF when we found the CDF of m, when we did this m, and then the integral from 0 to m, okay, of the function 2x over 9, and then dx. So when we evaluated this, we found that our CDF was the, okay, m squared over 9. So here I'd put m because I was finding the what? The median. So now when you're finding Q3, just replace this m with Q3 here, Q3, here, Q3. That's what you are seeing there, okay? So we are equating now this CDF to 0. What? 75. So it will be Q1, Q3 squared divided by 9 is equals to 0.75. So it will be Q3 squared is equals to, okay? So let's multiply. So 9 multiplied by 0.75. Okay, 9 multiplied by 0.75. What am I going to get? Okay, so 0.75. What's wrong with my calculator? 0.75 multiplied by 9. I'm going to get 6.75. Okay, and then you take the square root, even there the square root to be Q3 is equals to. Okay, so approximately when I take the square root of this, it's giving me 2.6. Approximately, so 2.6. Okay, when you round it off. All right, so it means that is my Q3, so 2.6. Our Q2 is this, our Q1 is that. So we found all the quartiles there. Okay, so time to find some probability. Okay, so remember our CDF, I'll write it now in terms of t. It was just t squared over 9. So we're going to use this guy to find some probabilities here. So they're saying, what is the probability that a randomly selected patient will take between 1 and 2 hours to recover? So here we're finding the probability, okay, that the time should be between 2 and what? 1. So this here is the same as, okay, this one here is the same as f of 2 minus f of 1. But if you want, you can just integrate this function that you've been given here, okay, over the interval 1 to what? 2. You can say the integral from 1 to 2 of this guy here, 2x and then 9 dx. So the answer that you're going to find here will be the same as the answer that you're going to get here. Okay, so here we're finding f of 2. So where there's t there, I put 2. So it will be 2 squared over 9 minus, where there's where there's t, I put 1. So 1 squared over 9. So this will be 4 over 9 minus 1 over 9. So what are we going to get there? Okay, what are we going to get? So we can say 4 minus 1 over 9. So that would be 3 over 9, which will just be 1 over 9. So the probability that the time will take between 1 and 2 hours will just be 1 over 9. So even if you use the integral here, you're still going to find the same ones. So let's try. We see if it will be correct. Okay, so I'm going to say the probability that the time is between 1 and 2, just the integral from 1 all the way to 2 of this guy. Okay, since I have t here, I'm going to write this one in terms of t. It doesn't change anything, it's just a variable. So it will be 2t over 9 and then dt. Okay, so the 2 over 9 can come outside, and then I integrate the t that will remain here. So it will be t squared over 2, and then I have 2 as the limits, and then 1. So this will be 2 over 9. Okay, and then here it will be t is 2 now. So 2 squared, it will be 4, divided by 2, it will be 2, minus 1 squared over 2, which will just be half. Okay, so this is what I have. So from there, it will be 2 over 9. Okay, it will be 2 over 9. And then on the other side, what do I get? So what is 2 minus half? Okay, so it will be 2, 4 minus 1. So it will be 3 over 2. So it means in the brackets, I have 3 over 2. So 3 over 2, these 2 and these 2 cancel out. So I remain with 3 over 9, which is the same as 1 over what? 9. So you choose the best method for yourself. Okay, either this one or the one that we use the what? The CDF. So that's the good part about finding the CDF, because it makes finding the probability very, very easy. All right, so let's look at the last question on this set of questions that we are solving. So we're now looking at I. So I, they're saying, what is the probability that a randomly selected patient would take at least 3 hours to recover? So at least means 3 hours or more. Okay, but we see here from our interval here, the highest value we can go is 3. But here they are asking us to find the probability that x is greater than or equals to 3, because this is what it means to be at least. So this one here, you can also solve it using the complement rule. So you say, whenever you see a greater than here, okay, you can rewrite this probability as the probability of, can rewrite it as 1 minus the probability of x, okay? So since here it was greater than or equal to 3, here we're going to say less than 3. Okay, we're going to say less than 3. All right, so what is the probability that x is less than 3? So it will be 1 minus, this probability is the same as f of what? 3. So this here will be 1 minus, what was our f function? So our CDF was t squared over what? 9. So where there's t now, I'm putting what? 3. So it will be 3 squared over what? 9. So this will be 1 minus 9 over 9, which is 1 minus 1, which is just 0. Okay, so the probability that the patient will take at least 3 hours to recover is just 0. Okay, because 0, because 3 here is the highest point, so you can't go beyond that. So the probability of anything that is beyond 3 will just be what? 0. Okay, because it's not defined by this PDF that we've been given. Right, so that is it for this question. We continue looking at continuous random variables. Okay, so what do we know about continuous random variables? We know that the probability of f of x, okay, should be between 1 and what? 0. And then the integral, okay, from the lowest point in the interval that we've been given to the highest point that we've been given of f of x should always be equals to 1. Okay, so you use this to test if something is a PDF or not, or to find something like the missing values of k. Okay, and then we also know that the expected value of x will just be equals to the integral, okay, from the lowest boundary to the highest of f of x dx. So here I forgot a dx. Okay, and then the variance of x is simply the expected value of x squared minus the expected value of x, and then I square it. Okay, so to find this one here, you just change where there's x here, you put x squared. Right, so those are the common formulas. And then to find the standard deviation, we're just going to take the square root of the what? The variance. Okay, so these are the formulas that we'll be using to find some of these questions. Okay, maybe I can also give the formula for finding the CDF. So CDF, which is the cumulative distribution function, which is given by F, a capital F, and then you can put any variable here, maybe T is equals to the integral, okay, the integral from the lowest point up to this T of whatever function that you have here, and then dx. Okay, so we're going to be using this one here to find the CDF. Then when we are finding the median, okay, we're going to be equating this CDF to 0.5. So the median is also known as Q2. If we're finding Q1, we'll be equating this CDF here to 0.25. If we're finding Q3, we'll be equating this CDF to 0.75. Okay, and then the other thing can be the formula for finding the probability. Okay, so let's say I'm finding the probability between some values. Okay, maybe find the probability that X, okay, is between maybe A and B. So this one here is the same as the integral from A all the way up to B of the f of X and then dx. If you don't want to use the integral part, you can use the CDF. Okay, so you're going to say this probability that X is between A and B is the same as f of B minus f of A. So make sure you don't confuse these ones here. This one is the CDF. So this F here should be a capital F. Okay. And then for the PDF, we use a smaller letter F. So now let's look at this question here. Okay, so they're saying a research study examines the time it takes for a newly developed drug to reach peak effectiveness in patients. The drug's effectiveness time measured in hours is modeled by the probability density function, which has been given here. Okay, so this one says the probability is 3/2 and then 1 minus x squared for all the values that are between 0 and k. Okay, for all the x values that are between 0 and k. And then if you pick a value that is outside this interval, okay, your probability will just be what? 0. So that's what this 0 otherwise means. Right, so let's look at the first question. They're saying given that the function is a valid probability function or a valid PDF, find the value of k. So this is the k that we are finding there. Okay, so we know that if something is a valid PDF, okay, then the integral over the given interval, okay, which is 0 to k, of this f of x, which is given by 3/2, 1 minus x squared dx, okay? This integral here should give us what? 1, if this is indeed a valid PDF, and they have told us here that it's a valid PDF. So we're going to use that fact to help us find the value of k. Okay, so the laws of integrals, we can move this 3/2 to the front. So what we have will be 3/2, the integral of 0 to k 1 minus x squared, and then dx. This should be equals to 1. Okay, so what we have is, I'll continue it from here, 3/2, and then let's integrate here. Okay, so when we integrate 1, okay, 1 is the same as 1x to the power 0. So I add 1 to this x, okay? I'll just get x and then divide it by the new power, which will just be 1. And then I go to the other one, which is x squared. So I add the 1 to this power to be x to the power 3, and then I divide by that same power. So it will be x to the power 3 divided by 3, and then the limits are k and 0. So I write 0 and k. This should be equal to 1. Okay. And then from here, it means we're going to have 3/2. Then here we can substitute this k into this equation. So I'm going to get k minus k to the power 3 over 3, and then is equals to 1. Okay, so I didn't include this 0 here because if I put this 0 here, I put the 0 there, I'm just going to get 0. Okay, and then from here, we can multiply. Okay, we can multiply with this. So it will be 3 over 2k minus 3 over 2 multiplied by k to the power 3 over 3. So this 3 will cancel with this 3. So what I end up having is k to the power 3 divided by 2. This is equals to 1. Okay, so from here, I want to get rid of the fractions. So what do? I multiply throughout by the denominator, which is 2. So I multiply by 2 throughout. So if I multiply by 2 throughout, it means this 2 and this 2 will cancel, this 2 and this 2 will cancel. So I'll remain with 3k minus k to the power 3 is equals to 2. Because I'm multiplying 2 with this, and this. So that's where this 2 is coming from. So we notice there that we have a cubic what? Function. So that's why you learned the cubic function. So you use the root test to test for factors here, because you have maybe we should move all of this to the other side. So it will be k to the power 3 minus 3k and then plus 2 is equals to 0. So what I've done here, I've just moved this one to the other side, this one to the other side. So I now have this. And then from there I can look for some factors. Okay, I can look for some factors. So let's try to test maybe k minus 1. Will it work there? So k minus 1, it means our k will just be equals to 1. So if I put 1 here to be 1 to the power 3 minus 3 multiplied by 1 plus 2 is equals to 0. So 1 plus 2, it will be 3 minus 3, 0. All right, so it means this guy here is a factor. Then from there, we can use synthetic division. So don't forget your synthetic division. Okay, so what did I have now? I've erased everything. Okay, I can just erase this part. So we know for sure that k is equals to 1 is a factor. So let's use synthetic division. So I have 1. And then from this equation here, okay, I should make sure that the powers are dropping down smoothly. So the first one is k to the power 3. So the next one should be k to the power 2. But it's not there, so I'm just going to write 0k to the power 2. Then minus 3k to the power 1 plus 2k to the power 0. But this k to the power 0, we don't show it, so it's just a constant there. K is equals to 0. So I'll get the coefficients from this now. So the first one is 1, then I have 0, and then I have minus 3, and then I have 2. Okay, so I bring down this one, and then I multiply with that one, I get 1. 0 plus 1, 1. 1 multiplied by this, I get 1 again. If I add minus 3 and 1, I get minus 2. 1 multiplied by minus 2, get minus 2. 2 plus minus 2 gives me 0. Okay, perfect. So it means now we have like a factor there. Okay, so it means the function that I had, k3 and then minus 3k plus 2, okay, is the same as k minus 1. This is the first factor. And then this one here becomes the quadratic equation, which will just be x squared plus x minus 2. So why? Because this one is 1. So you just add x squared here. Here you add x, and then this one you leave it the way it is. Okay, so the power here was power 3. When it comes here, it drops by 1 power. So we get that one there. Okay, and then that one there, we can simply factorize it. So it is x squared plus x minus 2. So how can we factorize this one? Okay, we see that the factors will just be plus 2 and minus 1. So this will be x plus 2. Okay, should write this in terms of k, right? So this is k, this is k used with x. This is also k, and k there. So the factors here will just be k plus 2 and k minus 1. So how are we getting this? We're saying the product there is minus 2, the factors will be 2 and minus 1. The sum will be 1. So when you add this, you get 1. When you multiply, you get minus 2. So you end up with this. So try it out. You should end up with this. So it will be k minus 1. And then here, when you factorize it, it will be k minus 1 as well. And then k plus 2. Okay? So remember, we are finding the value of k. And from this interval, they're saying 0 to k. So it means this k here should be greater than 0. Okay? Should be greater than 0 because they're starting at 0 and then they're going to the positive direction here. So from this one and this one, I'll get k is equals to what? 1. From this one, I'll get k is equals to minus 2. But this one here cannot be the answer because they said k is actually greater than this 0. Okay, so we conclude here that k is just what? 1. So it means our interval is 0 to 1. Okay, so the value of k is 1. Okay, so we're done with part A. Let's look at part B. So part B, they're saying sketch f. Okay, so sketch f. F is just 3 over 2 and then 1 minus x squared. So we are sketching this f over this interval only, okay, and nowhere else. So what we notice that this guy here is just a quadratic equation. So when I expand, I'm going to get 3 over 2 minus 3 over 2x squared. So this is a quadratic equation. So how do you sketch a quadratic equation? You find the y-intercept. So the y-intercept is the guy that does not have any x here. We can see it is 3 over 2. Then we find the x-intercept. So how do you find the x-intercepts? You equate this equation to 0. So if we do that, we're going to get 3 over 2 minus 3 over 2 x squared is equals to 0. So it is 3 over 2 x squared is equals to 3 over 2. Then we divide both sides by 3 over 2. We're just going to get x squared is equals to 1. Okay, square root of both sides, we're going to get x is equals to plus minus 1. So it means these are the x-intercepts. Okay, x is equals to minus 1 or x is equals to 1. Okay, what else do we need? We need the turning point. Sure. All right, so now let's find the turning point. Okay, so we can multiply this with this. We are going to get 3 over 2 minus 3 over 2x squared. Okay, so the x coordinate of the turning point is minus b over 2a. So we see that we do not have a term in x here. Okay, so it's just going to be 0 over 2. Our a is minus 3 over 2. This is just going to be 0. Then our y coordinate of the turning point, we're just going to say f of 0. Okay, so this 0, you put it in f, we're going to get 3 over 2. So it means the turning point here will just be 0, 3 over 2. Right, and then from there now we can sketch this function. Okay, so let's write our y-axis here. And then we can put our x-axis there. So remember, we are drawing this curve in this range. Okay, so if I have 0 there, 1 can be somewhere there, minus 1. Okay, so let's first of all draw a full curve. So we're saying x-intercept, x-intercept. Okay, turning point is 0, 3 over 2. So 3 over 2 can be somewhere there. So 0, this, that's the turning point there. Okay, so the turning point is also the same as our y-intercept. So we can draw a curve here like that. Okay, but remember, we said the probability is always equal to 0, is always between 0 and 1, right? So it means this graph here should not cross like that. Okay, because if it crosses, it means our probability is negative there. And then even this side here, this part here, I'm not going to draw it. Why? Because we're just drawing this graph on the interval 0 to what? 1. So this part here, starting from here all the way up to here, I'm going to erase it. Okay, I'm going to erase it. So we erase this part like this. Okay, so the part that they want you to you to show them just this part here. So it's a smooth curve like that. So it's not a straight line, it's a curve because it came from here and then it went like that, right? Okay, so it's a smooth curve. So don't draw a line here, draw a smooth curve like that. Right, so this part here is the graph that they want, which is 3/2, 1 minus x squared for the interval 0 to what? 1. Right. And then let's look at C. So C, what do we have? C, they're saying find the mean time for the drug to reach peak effectiveness. Okay, find the mean time for the drug to reach peak effectiveness. So we said mean is just the expected value of x. So the integral, okay, from 0 to 1, remember we're using this integral of x multiplied by the probability function, which is 3/2, and then 1 minus x to the power 2, and then dx. Okay, so here I can take this 3/2 outside there. So to be 3/2, the integral of 0 to 1, then x multiplied by 1, x multiplied by x squared minus x to the power 3, and then dx. So this is going to be equals to 3/2, and then I can integrate this. So if I integrate the x, I get x squared over x minus, if I integrate x to the power 3, I get x to the power 4/4. And then the limits is 0 to 1. Okay, so from there, what do I get? Okay, I just substitute 1 there, because if I substitute 0, I'm just going to get 0. So to be expected value is equals to 3/2. Okay, and then I put 1 on the x squared there. Okay, so this is 2. So I put 1 on the x squared, I get 1/2 minus, if I put 1 there, I get 1/4. So this is what I have. So I don't have to substitute 0 because I'll just get 0. So what is 1/2 minus 1/4? So 1/2 minus 1/4, common denominator is 4. 2 into 4, it's 2. 2 multiplied by 1, 2 minus. Okay, so this will just be 1/4. So I write 1/4 there, and then just multiply with the 3/2 outside. So what you're going to get there will be 3/6 over 8. Okay, so 3/8 will be our mean. We can find it as a decimal to be 0.375. Okay, so this will be our mean there. Right, so we can keep this mean in case we will need to find the variance somewhere. So I have 3/8, which is the same as 0.375. So that is our expected value of x, or our mean time for the drug to reach its peak effectiveness. Okay, and then let's look at D. They're saying calculate the variance, okay, in the time it takes for the drug to reach its peak effectiveness. So we know that the variance of x is equals to the expected value of x squared minus the expected value of x squared. So let's find the expected value of x squared. This will be the integral from 0 to 1 of x squared multiplied by 3/2. Okay, multiplied by 3/2 and then 1 minus x squared dx. Okay, so let's take the constant out. So we have 3/2, the integral of 0 to 1, x squared multiplied by 1, x squared minus x squared multiplied by x squared, x to the power 4 dx. So this is what we have, okay? And then from there, we can just do the integral and then we substitute. So this will be is equals to x 3/2 if I integrate x squared, I get x to the power 3 divided by 3. So you just add 1 to this power, and then you divide by that same new power. Minus, if I add 1 to this, I get what? I get x to the power 5 divided by 5. And then the limits are 1 to 0. Okay, let's substitute. So to be 3 over 2, in the bracket, I'm just going to have 1 over 3 minus 1 over 5. Because when I substitute by 0 there, it will just be zeros. Okay, so 1 over 3 minus 1 over 5. What are we going to get? Okay, so we're going to get this. Can you erase this part? So we say the expected value of x squared is equals to 3 over 2. And then inside here, okay, if I subtract these two, I'm going to say common denominator is 15. 3 into this is 5 minus 3, so it will be 2 over 15. So write 2 over 15. Okay, so meaning this 2 and this 2 can cancel. So I remain with 3 over 15. 3 into 3 is 1, 3 into 15 is 5. So this one here is my expected x squared. Okay, or the expected value of x squared. Now we can calculate the variance. So we're going to say variance of x is equals to expected value of x squared minus square the expected value of x. So it is 1 over 5 minus 9 over 64. Okay, so now we just have to combine these two. Okay, we just have to combine these two. So when we combine them, we get 19 over 320 is equals to 0.059375, something like that. So this is our variance. Okay, of course, the following question will be determine the standard deviation. So once you have your variance, then you should smile when they ask you about standard deviation. So standard deviation will just be the square root of the variance. So the square root of 19 over 320 is going to be equals to, okay? Right, so when I punch my calculator, it's giving me approximately 0.243. So kindly confirm with your own calculators as well. So that would be our standard deviation. Okay, and then we move on. Okay, we're still dealing with this same function, but now we want to find the mode. Okay, so the mode, remember, we said it is the value of x that gives this probability function, okay, the highest probability. So we can get that from the graph. So remember the graph that we had here. Okay, we had 0 and then 1. So we said the graph came from minus -1 like this, and then it went like that, right? Then we said this part here, we can't draw it because the probability function says from 0 to what? To 1. Okay, the probability function said the x is between 1 and 0. So we're just considering this part of the curve. So what is the highest probability on this curve here? The highest probability is at 3 over 2, which we said was our y-intercept or our turning point. Okay, our y-coordinate of a turning point. So what value of x makes us to get this highest value? Okay, the value of x here will just be what? X is equals to 0. It's the one that gave us 3 over 2. Okay, so it means the mode of this distribution here is just x is equals to 0. That's the mode. Okay, that's the mode there. So you just look for the value of x that will give you the highest probability. Okay, so whenever you're given a quadratic equation here, just get the value of the turning point. Okay, just get the value of the x coordinate of a turning point, because we said the x coordinate was minus b over 2a. And in this equation, since we can't see the term with x, we said b was 0 over 2a. So this is 0. So the x-coordinate of a turning point is the one that will make the probability to be the highest. So it becomes the mode. So the mode is just x is equals to 0. Okay, and then the median. Okay, so whenever given the median there, we first have to find the CDF. So CDF is equals to the integral from the lowest limit, which is 0, okay, all the way up to a variable, let's say t. Okay, and then we can put our function here, then dx. Okay, so when we find here, we're going to find 3 over 2, and then the integral of 1 just be x minus the integral of this will be x to the power 3, and then okay, x to the power 3, and then the power 3 like that. Okay, so that's what we get when we integrate this. So it means here I have t and then there's 0. So our CDF is just going to be equals to 3 over 2. Okay, and then you put in the t there. If you put in the 0, you're just going to get zeros. So it will be t minus t to the power 3 divided by 3. So this one here is our CDF. So we're going to be using our CDF to find the median, the quartile 1, the quartile 2. The quartile 3, I mean. So the median is the same as the Q2. Okay, the median is the same as the Q2, and then we can also find Q1, Q3. So if we're finding Q1, we're going to equate this CDF to 0.25. If we're finding Q2, we're going to equate this CDF to 0.5. If we're finding Q3, we're going to equate this CDF to what? 0.75. So this Q2 is the same as the median.